In this video, we will see dry run of the code. Now let's quickly check the dry run of this code. Okay, so basically we have the same binary tree. Okay, and let's see how recursion functions will work. So I will call this first function max depth with the value of root node, that is 3. So I will call max max depth 3. Let me put here md 3. Now I will come to this function. Is the root is equals to null? So I will check the return of maximum depth of root dot left. So again one function calling, right? Again one function calling. So I will first call this function maximum depth of root dot left. What is root dot left? That is 9. So I will call maximum depth 9. Again I will first execute this function. Is the root is equals to null? No, the root is not equals to null. Again, I will return here maximum depth of root dot left. What is root dot left? That is null. So again, I one function I will call, that is maximum depth with the null node, right? With the null node. Okay. Now, is the root is equals to null? I will calling this function. Is the root is equals to null? Yes, it is equals to null. So return 0. So this will return 0, right? And once this is returning 0, what I will do, I will simply, can I remove this from the recursion list? Yes, because the work is done, right? Function null node called, okay, null node called, it returned 0. Okay, so done. The function is done for this null node. Okay, it returned to 0 here itself. Now, once this is done, I will come back to here, math.max root dot left is done. Then I will check maximum depth root dot right. What is maximum depth root dot right? That is again null, right? That is also null. So I will call again one function with the null value, null. Okay, let me with null. I will check, first execute this function. I will check, is my root is null? Yes, null. So it will basically return 0 to this function. Okay. So if it is returning 0, can I say my work done of this function is also done? Okay. Yes. The one function of this function is also done. Now we are at the which function? Maximum depth of 9. Right. We have checked the maximum depth of root dot left, that is 0. We have checked the maximum root dot right, that is also 0. So 0 and 0. What I will get the max of it? That is 0. Right. So I will return 0 plus 1 to it. So for 9, I will return 0 plus 1. That means it will be, right, basically for this value, it will be 0 plus 1. So it will have one value, right? So now can I say my work done of maximum depth with the 9 node is also done? Yes, it is done. Okay. So what I will do, I will move back to my MD3 node, maximum depth of third node, right? From third node, we have checked, let me remove all this thing. From third node, we have checked the root dot left. That was maximum depth of 9. Then I will call to maximum depth root dot right. So then I will call maximum depth of root dot right. What is right? That is 20. So I will call maximum depth root dot 20. MD with the 20. Root, that is root of 20. Okay. Now, first I will execute this function. Is my root is equals to null? No, it's not equals to null. Then I will return maximum depth of root dot left. What is root dot left? That is 15. So I will call MD15. I will call this function MD15. Okay. So first I will execute this function. So if I am executing MD15, is my root, that is 15 root, is null? No, it's not. Again, one function call I will call maximum depth of root dot left. What is 15 left? That is null. Again, right here, that is null. Okay, so I will call MD with a null. This null will return 0, right? So it will return 0. And can I say the work done of null form root is also done, right? So root dot left is done. Then I will check maximum depth root dot right. What is 15 root dot right? That is also null, right? So I will call this function with a null value, right? And if my root is equals to null, yes, so it will also return 0. Okay, it will also return 0. Once this is returned 0, okay, now I have maximum depth root dot left 0, root dot right 0. What is max of it? That is also 0. So I will return 0 plus 1. That will be plus 1 to it. Okay. And I will again move back to my last function call. So here in the last function call, we have checked maximum depth root dot left, right? Basically, we have checked here for 20, the 15, right? So I will say from here 20, we are getting plus 1 for 50. Then I will check maximum depth root dot right of 20. So what will be maximum depth of root dot right? That is again one function called MD with 7 root. So I will again call one function MD with 7 root. Now first execute this function. Is it root is equals to null? No, it's not. Okay. So I will come here and I will again one function call root dot left. So again one function call root dot left. What is the root dot left? That is null. So it will be null. Okay. So when this is null here, it will return 0 to it, because if root is null, return 0. So I have called MD here null. Okay. But with the root of 0. So what I will do, okay, is 15 work. 15 work is done. So let me remove this one, because the work done of 15 is all not done. So let me remove 15 from here. Okay. So we have null. Null is returning 0. So can I say work done of null is also done, right? I will come to here 7. Now for 7, I will check root dot right. What is root dot right? Again, maximum depth with the null value, right? I will check is root is null. Yes, it is null. It will also return 0. So it will also return 0. I will put MD null, but that will directly return 0. So I will simply remove from the stack. And for MD7, I have calculated root dot left, that is 0. I have calculated maximum depth root dot right, that is also 0. I will take the maximum. What is maximum? That is 0 only. So I will do 0 plus 1. So if I add 0 plus 1, it will be plus 1 only. Alright. So from here I am getting 1. From here I am getting 1. Right. Now what I will do? For this 20, I have calculated the left. I am getting plus 1 here. For 20, I calculated the right. I am getting plus 1 here as well. Right. Let me remove this one. I am getting plus 1 here as well. Here as well. Right. Which is maximum? Right. Both are equal. So anyone you can take. I can take 1. Now from 1 plus 1, it will return to 20. So I will return max.max, that is 1 plus 1. So I will return 2 to it. So for MD, I will return 2. Right. So can I say, first of all, 7 work is already done. Okay. And now when I'm returning 2 with MD20, so that is also done. Okay. Now we are at the maximum depth of 3. So for 3, we have calculated maximum depth of 9, that was 1. Okay. And maximum depth of 20, that was 2. Right. So we have calculated the root dot left of 3, that is giving maximum depth as 1, and that is giving 2, which is maximum 2. So I will take maximum and I will add plus 1. So 2 plus 1, it will be 3, and I will return with the value 3. So now if I am returning with the value of 3, can I say my work done of maximum depth of 3 is also done? Yes. So work is also done of maximum depth. Okay. And I am returning with 3. So yes, now all the things are completed. Your stack is also empty and your answer is 3. This is how it is working. So this is basically your recursion. Now let's talk about the time and space complexity. So here time complexity, again you are visiting each node once only. You are visiting each nodes one. So the time complexity again will be big of n, and your space complexity. You checked your maximum recursion stack, right? When I was filling. So the recursion stack at maximum was 3 only, right? At maximum was 3. That is again to the height of your maximum depth of the root node. So basically that will be again height of the tree, right? So space complexity will be height of the tree. And again, what is this space complexity? It is of your recursion stack memory, not an external space. So again, the space complexity is only because of recursion stack memory. Okay, none of these spaces. So this will be the time complexity and space complexity. So yeah, that's all about maximum depth of the binary tree. In the next video, we will check out one more problem, that is same tree. Okay. So if you want, you can go ahead, check the problem same tree. Otherwise, in the next video, I will discuss the same tree complete with the dry run.